There are four types of expressions that you're going to need to know how to factor. For starters, we need to be looking out for greatest common factor every single time. So for instance, number 38 here, I can see that I can divide each of these numbers, the 3, the 27, and the 60, by a 3. So I'm going to show that like this. But I also want to take a look at the variables. Do each of those terms have the same variable in them? Yes. In that case, I want to look for the smallest of the exponents, in this case a 1, or just an x to the first. And I'm going to put that x down there along with the 3's. So my GCF is 3x. And that means the 3x becomes my coefficient. And what I'm left with is 3 divided by 3 is 1, x to the third divided by x to the first. Remember, we subtract. 3 minus 1 is 2, so x squared. 27 divided by 3 is positive 9, which leaves me with 9, and then x squared divided by x. 2 minus 1 is 1. Remember, you don't need 1 as an exponent. And then these x's will go away. 1 minus 1 is 0. And 60 divided by 3 is 20. So again, you're always looking out for that greatest common factor no matter what. Now, once you've identified the greatest common factor and divided through by that GCF, please make sure to put it out front. But also remember, can you factor what's left over on the inside? And this brings us to our second type of what can we factor. And in this case, we can factor, since a is equal to 1, right, this is standard form of a quadratic equation, a is equal to 1, so I need two numbers that multiply to 20 and add up to 9. The nice thing here is that all of my values are positive, so it's either going to be 1 and 20, 2 and 10, or 4 and 5. And since 4 plus 5 is equal to 9, we're going to choose those two values. So what we're finally left with is 3x times x plus 4 times x plus 5. Now, if you're not able to identify a GCF, the next thing you want to think about is how can I factor this expression? And the first type that we factored was here, where we're in standard form, but it's equal to, the a is equal to 1. Another type of quadratic we're going to factor is your difference of squares. Remember, when it's a difference, it's got to be a difference. Okay, so it's got to be subtraction. You're going to take the square root of the first term. Remember, squares and square roots undo each other, so the square root of x squared is x. And you'll take the square root of the second term, which is 49. Don't worry about that negative. That negative tells me that it's a difference of squares. Square root of 49 is 7. And what we're left with then, that factors into our two parentheses, our two binomials, the square root of the first term in the first spots, the square root of the second term in the second spots. Difference of squares means different signs. Okay? So that's our third type of factoring, right? We did GCF. We factored when a was equal to 1. We factor a difference of squares. And then finally, we're going to think about what can I factor when there is no greatest common factor, right? I don't have an x in all of my terms, so x doesn't count. And I cannot divide everything by anything other than 1. So what we're going to do is we're going to remember that 5x squared is 5x times 1x. Actually, let's put the 1 there. We won't need it eventually, but we'll leave it there. And then negative 6 can be a 1 and a 6, or a 2 and a 3. But remember that it's negative, so we either want negative 1 and positive 6, or positive 1 and negative 6, and then negative 2 and 3, or positive 2 and negative 3. So there's 4 options that we're going to guess and check. Guess and check works like this. We're going to set up our two sets of parentheses. We're going to plop in that 5x and that 1x. And then we're going to play around with the negative 1 and 6, the negative 2 and 3, the 1 and negative 6, the 2 and negative 3. We're going to see what happens, see what works to end up with that positive 13x in the middle. So let's try it. Let's start with the first one that I wrote, negative 1 and positive 6. and see what happens. Well, 5x times 6 is 30x, and negative 1 times x is negative 1x, and if I add those two together, I get 29, so that doesn't work. Nope. And so I'm just going to erase those, and I'm going to start over. Let's do negative 2 and 3. Negative 2 and positive 3. Negative 5 times 3 is positive 15x, and negative 2 times x is negative 2x, and oh, that one works. Negative 2x plus 15x is equal to 13x, which is exactly what we wanted for that middle value, that b value. So my final factored form here, and we'll rewrite it just so it's a little bit neater, 5x minus 2 times x plus 3.